Hello, everyone. Today we're going to continue with other theorems involving parallel lines and perpendicular lines. So this is what I'm calling 3.5. So here in our diagram, we have that we're given A is parallel to B and B is parallel to C. I want to prove A is parallel to C. Well, it's really just one step. You cannot say it's substitution or transitive because it's not. But it is the theorem if two lines are parallel to the same line, they are parallel. And hopefully you see that in the diagram. So our theorem is if two lines are parallel to the same line, they are parallel. Now you can't say transitive or substitution because here we have another idea where we know that M is perpendicular to T and N is perpendicular to T. Therefore, 1 and 2 are both right angles, and that's the definition of perpendicular. And then 1 is congruent to 2 because all right angles are congruent. And then we know that M is parallel to N because if 1 and 2 are corresponding angles are congruent, then parallel. Now, the good news is we can summarize that and we can make up a new theorem. And our new theorem, which we're not really making up, we just kind of proved it there, is that if two lines are perpendicular to the same line, they are parallel. So now let's see how we can use this. So in number 3, we know that M and N are parallel and N and T are perpendicular. Oh, actually, we're not going to use those. We're developing our third theorem. So we know 1 and 2 are congruent because parallel implies corresponding angles congruent. We know 2 is a right angle because it's definition of perpendicular. Measure of angle 2 equals 90, and that's definition of right. Angle 1 equals 90 because of substitution. And therefore 1 is a right angle, which is definition of right. And therefore M is perpendicular to T, which is definition perpendicular. So all that was really going a long way to say our other theorem, which is if a line is perpendicular to one of a pair of parallel lines, it is perpendicular to the other. So now here's where we start our examples using those theorems. So we have this problem, and I want you to pause and try to come back and give it a start. Okay, so hopefully you paused and gave this a try. So I'm writing out my givens that A is perpendicular to S, C is perpendicular to S, and A is parallel to B. So I know since A and C are both perpendicular to S, then I know that A is parallel to C because our theorem we just learned today is if two lines are perpendicular to the same line, they're parallel. Then we also know A is parallel to B, so that would mean that C is parallel to B, because the other theorem we learned is if two lines are parallel to the same line, they're parallel. So now here's another example. So we're going to start out by writing our statements, reasons, and our givens. And you should pause and give it a try, and then come back. Okay, so hopefully you paused. So we know that AD is perpendicular to CD. We know that 1 is congruent to 2. And I want to know that BC is perpendicular to CD. Well, knowing that 1 is congruent to 2, that tells me that BC is parallel to AD. And that's because if alternate interior angles are congruent, then the lines are parallel. Then I know that BC is perpendicular to DC, because if one of two parallel lines are perpendicular to a third, the other is. And those are our additional theorems. If you have questions on any of these, please bring them to class.